Welcome to viewers and students. Here we will discuss a few important construction. First, to draw a perpendicular on a line from an external point. So let us first draw a line. Suppose this line. So let us name this line as L. Now imagine an external point of this line. Say this is one point P, suppose. Now from P we will try to draw a perpendicular on this line. P is an external point for the line L. Now we will draw a line which is perpendicular from P to L. So we will first draw an arc on this line, right? From P we will draw an arc intersecting this line in two distinct points. So this is an arc. Now this arc is intersecting this line at point A and B, suppose. Now we'll try to measure the distance between A and B. This distance between A and B is this. You put the tip of the compass at one point and tip of the pencil in the other point. So this is the distance. Now taking this distance as a radius, we will draw two different arcs from A and B. Now we find the point of intersection of these two arcs. So let us join this point of intersection. Say it is C. Let us denote this point, suppose C. Now let us join P and C. Let us join P and C. Now this line PC intersects the line L at this point. Suppose this is Q. Now let us measure this angle here now. We'll try to measure the angle subtended by PC with L. So what is the measure of this angle? You see, this is right angle. That means this angle is 90 degree. So PQ is perpendicular. This is the symbol of perpendicular to line L. Thus we construct a line which is perpendicular to the line L. This line is perpendicular line is drawn from an external point P on the line L. This is how you can draw a perpendicular on a line from an external point. Now next construction we will do is to draw perpendicular at a point on a line. Suppose this is a given line. You are given this line. Suppose this line is L. Now say this is the point P, suppose. Now you have to draw perpendicular at this point P. So let us start with this. Let us draw an arc of any radius with at point P. We draw an arc at point P with any radius. Now this arc intersects the line at Q, suppose. This is Q. Now with Q as the center, let us draw the arc with the same radius. Say this is Q and this is R, right? So we draw the same arc of radius, same radius with center at Q, right? Now with P as a center, this is R. Now R as a center, let us draw another arc of the same radius. Say this is S. Now with S as a center, let us draw another arc. So this is, suppose this point of intersection is suppose T. Now let us join T with P. This T with P. Now this line is perpendicular the line PT. PT is perpendicular to line L. Right? PT is perpendicular to L. This angle is 90 degree. This is how we can draw a perpendicular at a point on a line. Let us do it again. Let us draw this line again. Suppose this is line L. So you take a point here, say it is P. Now we have to draw perpendicular at P. So first, taking P as a center, draw an arc of any radius. Say this is the arc we drawn. Now this arc intersects this line L at Q. Suppose this point is Q. Now taking Q as the center, let us draw an arc of the same radius. Now suppose this point is R. Now taking R as a center, let us draw an arc of the same radius again. Say it is S. Now taking S as a center, let us draw another arc of the same radius. This is suppose T. So let us join P and T now. Now we got that PT is perpendicular to line L. Let us check this with protractor. Try to measure this angle. You see, this is exactly 90 degree. This angle is 90 degree, right? So what we did, we made 4 arcs of the same radius. First, this arc, suppose this is S1. Suppose this arc is S1. This arc is suppose S2. This is S3. This is S3. And this is S4. So total we made 4 arcs of the same radius. Same radius means radius is equal to PQ. Same radius. You see, this arc is also radius PQ. Third arc, this is also radius PQ. Fourth arc, this is also radius PQ. Same radius. So we made total 4 arcs continuously, and last moment we joined the point of intersection of the third and fourth arc with P. We got the line perpendicular at P. Now we will discuss a few things about triangle. First we will discuss about median of a triangle. Median of a triangle. So what is median of a triangle? Let us draw a triangle. Suppose this is triangle ABC. Now let's imagine this is the midpoint of BC. Now let us join A and D. Now this line is called median of this triangle, right? AD is called median. AD is the median. So median means the line segment joining a vertex to the midpoint of the opposite side. Now what is the midpoint of the opposite side of B? B is the vertex, right? Now opposite of B is AC. Say midpoint of AC is D, E. Now let us join BE. So BE is another median. Let us suppose F is the midpoint of AB. Let us join CF. So CF is another median. There are 3 medians of a triangle, and medians of the triangle pass through a common point. This point is called centroid of the triangle. This is called centroid. Centroid means this point is middlemost point of the triangle. Middlemost point, centroid. So what is a median? It's a line segment joining a vertex to the midpoint of the opposite side, right? midpoint of the line segment opposite of vertex C is F. We join F, CF. Midpoint of the vertex opposite of this vertex B is E. We join BE. Similarly joined AD. Now all these three medians pass through a common point. This point is called centroid of the triangle. Now let us find practically manually to find the median of this triangle. So suppose this is the triangle. Now let us fold it in middle. Let us fold it in middle. So this is the center of this lower side. Let us join this opposite vertex, right? Similarly, let us find the middle point of this side. So this is the midpoint of this side. Now let us join the opposite vertex. So this is the line, right? Similarly, let us find the midpoint of this side. So fold it in middle. So we find the middle point of this side. Say this is the middle point. So let us join the opposite vertex. So we got the centroid of this triangle. This is the centroid, right? Centroid of this triangle. Now let us try to find the centroid of the triangle using compass. So first draw a triangle here. Draw a triangle here. Draw a triangle here. This is suppose ABC. Now let us try to find the middle point of AB. That means we will bisect this line segment AB into two equal parts. So let us find the middle point of AB. Taking AB as a radius, we will draw arcs here. Again, taking A as center, same radius, we will draw another two arcs. That means we got the middle point of AB here. Let us join the point of intersection of these arcs. So we got this middle point, right? Middle point of AB is suppose D. Let us bisect BC again, taking BC as a radius. BC as a radius. Let us draw arcs here. So let us join this point of intersection of these arcs. So we got the middle point of BC is E. Now let us bisect AC now. So we find the middle point of AC now, right? So this is suppose F. Now let us join the middle points with the opposite vertex. So vertex A to the midpoint of the opposite side. So this is E. Let us join AE. So this is one median. This is one median. Then vertex C with midpoint of the opposite side. So this is another median, right? Then vertex B to the midpoint of the opposite side. That means BF. You joined BF now, right? BF. So you find that the medians are passing through a common point. This point is called centroid of this triangle. So this is how you can find the centroid of the triangle with the help of compass, right? Okay viewers, thank you for watching this video. In the next class we'll discuss about orthocenter of the triangle. Orthocenter means it is the point of intersection of the perpendiculars, right? So let us discuss this in the next class. Thank you.